Now that we know the derivative is a function and how to work with it algebraically, we want to think a little bit more about how we understand and use the derivative of a function graphically. And so just some review questions for us to think about. How do we understand f prime of x? So that again is the derivative graphically, and maybe in perhaps relation to f itself, like the original function. And then also, how do we use f prime to inform us about f of x itself? And so to answer both of these, how do we understand f prime of x graphically? It's the rate of change. I'm not going to write this down, but it's the rate of change in f, right? So it's should be the graph of the graph of the tangent slopes of f, right? And then for the second question, how do we use f prime to inform us about f of x? Well, again, connected to the first one, right? If what we're seeing in f prime, if we're showing the graph of f prime, that is the graph of the slopes of f. So then we just have to sketch the graph using the y value that we see for f prime in that graph for this, and make that the slope of f at that given point. Okay, and so here is an example kind of going one direction. So we want to use this given f of x function to graph f prime of x. And then we want to ask ourselves what we notice about f and f prime. Okay, and again, what we did before is we kind of took different points on f of x, and I'm just going to do some of them, right? And we said, okay, let's think about the slope of f, or the slope of f at each of these points, right? And then that slope value is now our derivative. And so here at this first point, if I were to draw a tangent line, right, it's a steep tangent line that has a negative slope to it. So then the y value at that point is the slope. So I'm going to say something like this. At this point, it's still a negative slope, but maybe a little bit less. Here, it's starting to be pretty much 0. So again, the y value is indicating the slope. And then now here, our tangent lines are switching to become a positive slope. So now that has maybe a small positive y, and then here we have another, actually that was maybe pretty large. So something like that, and then here, and then this is still a positive slope, but maybe it'll become less positive, and then here at the top of the curve, it's 0 for the slope, and then we're back to negative slope, becoming more and more negative over time, and then less negative, maybe less negative. I took some points that are really close together, so I'm going to do something like this. And then here it's pretty much 0. Okay, so my derivative graph would look something roughly like this. And again, I don't have a vertical scale here, so I could be off a little bit. So this graph that I drew in green would be the derivative. Again, it's the graph of the slopes of f. Okay, and so just some connections here. We see that when the slope of f is 0, right, we touch the horizontal axis, and then negative and positive slopes so are seen as negative values or positive values respectively. Okay, and so just kind of summarizing some information and observations here. If we have a positive derivative, right, so like up in this region, right, what did we observe in the graph? Well, then that meant that the graph is increasing there. Okay, if we see that the graph has a negative derivative, right, and here, okay, then what we saw in the original function was that the function was decreasing. Okay, if we saw that the derivative was 0 at that point, so that's, looking, and I'll highlight those in green. So if the derivative was 0, so that'd be like right there and all along here, right? What happened on the function? Well, at this case, we saw a minimum. At this point, we saw a maximum, and here we kind of saw a plateau, right? So then there's kind of 3 different things that can happen when we look at, or if the derivative is 0. So we can say that f may have a local min, or local maximum. Okay, and so that is the idea that if we look at a number line at A specifically, right, it could be going increasing to decreasing, and so we might see some behavior like that going on. We can say F may have a local minimum, I can spell, okay, and so again, similar, here's A, and that would look like something going from decreasing to increasing, so it would go something like that at A. So it could do something like what we observe in like a graph of a cubic. It may have what we call a saddle, okay? And so what we would see there is that it would go something like this at A. So it would, increase and increase, stop and increase again, or decrease, stop and decrease. Or in the third case, or the fourth case that we saw is that F may be constant. And that's what happened at the end of our graph, okay? So just summarizing some observations. And so we kind of answered this already, but when would we know we would have a maximum, a minimum, and a saddle point? Well, again, we would see if we have a maximum at, say, A, and then I'll do minimum at A. I'll just get little sketches. So minimum would look something like that. And then saddle would go something like this or something like this. Let me just get these sketches going. Okay, then what we would see is that for a maximum on the left side of A, we would have it increasing, and then it would switch to decreasing. Minimum, decreasing to increasing. Saddle, again, we kind of mentioned this, increasing to increasing or decreasing to decreasing. But again, it would have to stop in between. So just some summaries or some observations from our graphs here about f and f prime. And we will use this to help us sketch the graph if we're given information about, whether the derivative is positive, negative, or zero at a given point.